This is the last stuff we're going to learn this year. You notice the planner. We're going to have mind jogger tomorrow. Then take a test over all this integer stuff. Adding, subtracting, multiplying, and dividing, and solving equations. We'll have a test on Thursday. We're going to do some computer work on Friday. Then next week we've got a holiday. Then we're going to do graphing. And then we're going to do review for the final. Then on Thursday, the next to last day of school, we'll have a final exam. And then the last day of school, I'm going to probably shove something up your nose. I don't know what we'll do that day. But we'll do something. Okay? Good deal? So that's what, this is it. This is the last stuff. Last notes, last everything. And it can be the most difficult. Meaning, it can be confusing. But if you'll stay with me and concentrate, it won't be that confusing, I hope. Because we've been doing algebra since 2nd grade. Right here is what it looked like in the 2nd grade. You remember having those little worksheets that had the blank, you know, the little box there? What goes in the box? Something plus 7 gives us 16. What goes in the box, children? 9. Very good. You did algebra. You have an equation because it has an equal sign. You have a missing number. You found the missing number. You have done algebra. You were doing that in the 2nd grade, but your teacher didn't call it algebra, did she? She said, we're going to find the number in the box. You were doing algebra. Okay? So, don't be scared of this because, why? You've already done it. The problem is, we're going to throw in a bunch of negatives and positives, and we're going to move things around to where they don't look so nice. But it's still all the same work. Okay? So don't be scared of it. Don't be scared of it. It just looks scary. It's really not scary. So, solving, y'all remember what solve means? It's a fancy mathematical word for what? Do what? Answer the question. I call it work it out. If it says solve on any equation through Algebra 2, through differential equations, calculus, if it says solve, then you're working it out. Work it out. We got to remember what a variable is. We've talked about variables before, haven't we, this year? What's a variable? Yeah, that's right. Good job. What's a variable? Look at all these problems. What's a variable?
Something missing.
Something missing, but how do we represent that missing?
A letter.
A letter. A variable is an alphabetical letter that represents a missing what? Number. Remember, a variable is a letter that represents a missing number. In 2nd grade, it was a box. We're not in 2nd grade anymore. We're mature mathematical students. We now put a letter. It's the same thing as that right there, y'all. Exactly the same thing. This box represents a missing number. Well, we're higher level students now. We're not going to use boxes anymore. We're not in elementary. We use letters. Same thing. There's a missing number right there we got to find that makes the equation true. Something plus 4 is going to give us 9 in a minute. Okay? In a minute. Now, we know what a variable is. The whole key to solving equations, to solving algebra equations, is we must get the variable by itself on one side of the equal sign. The whole key to solving algebra equations is we've got to get the variable by itself. We have done this earlier this year. I think we did it with proportions, where we had an x in there. Remember, our final answer was something like x equals 3. Do you see how the x is by itself on one side of the equal sign? Nothing is with it. Over here in our problem that starts here, there's a 4 with the x. Do you see a 8 with the n on the same side? Do you see a 5 with the y? Do you see a 10 with the z? But what are we trying to do, or what are we going to do? What? The variable. We got to get the variable by itself, which means this 4 has to leave, doesn't it? That means this 10 has to leave and go somewhere. It doesn't just fall off. It doesn't just disappear. We're going to do something to it. Over here, notice what's with the variable. Right here, there's something with the variable. This negative 4 is going to have to go somewhere, get out of here. But it's got to be done mathematically to get rid of it. Are you turning that over here so they can see what I'm talking about? You got to turn it, Holmes. Woo! No, you better sit down, Holmes.
I'm trying to go over there.
Ah, you're killing me. See, there's a 2 with the t, negative 2. That negative 2 is going to have to disappear. Over here on the last ones, there's a 7 with this w, right? So who's going to have to leave in a little while to get w by itself? 7's going to have to leave. Right here, what's going to have to leave? Negative 6, so y will be by itself. That's the whole key to working algebra. We've got to get the variable by itself. So our answers will be x is something, w equals something, z equals something. We got to know where we're headed so we can understand how we're going to get there. Thanks, brother. Fell down. Appreciate that. So, here we go. How are we going to do this? Well, I'm going to do a little explaining here. Come here, Case and Lowe. Get up here. You're going to be on the World Wide Web with me. Stand right here. Right there. All right. Mr. Lowe and I equal each other. I know I'm better looking, but for now, let's just play like we equal, okay? That means he's as fat as I am, all right? Stick it out there. No, stick it out. There ain't nothing there. All right, but he and I equal, okay? If I lose 10 pounds, in other words, if I subtract 10 from me to stay equal, what do I have to do to Kason? He's got to what? He's got to lose 10 pounds, or we're not equal anymore, are we? If he and I equal, and I lose 10 pounds, what has to happen to him? Do y'all understand? He's got to lose 10 pounds too. Even though he's on the other side of the equals, if I lose 10 to stay equal, he's got to lose 10. Okay? He and I equal. Let's say he gains 20 pounds. That's plus 20, isn't it? We don't equal anymore unless what happens to me? I got to gain 20. All right? Then we'll be equal again. Is everybody with me? What if Kason gets divided by 2? He gets cut right in half. What has to happen to me? I have to get divided in half, don't I? Or we will not be equals. The whole key is we've got to stay equal. So if something happens to him, it has to also happen to me. And if something happens to me, to stay equal, it has to happen to him. So that's what I'm going to use in working these problems. I'm going to say, okay, here's Cason's side, here's my side. If we do something to Cason, let's do it to me. You'll see it in just a minute. Thank you, Mr. Lowe. Now y'all got Cason on your brain. So here we go. So to do this, to get rid of the number that is with, I'm going to pause because I write faster than y'all. Hey, she's doing pretty good. That's right. You're going to take good notes in school and college, girl. Good job. As I say it, you put it. Some of you are to G-A-T rid of. Gotta learn to speed up. To get rid of the number that is with the var. What's var?
Variable.
There you go, variable. To get rid of the number that is with the variable, you do the opposite of what it is. Ta-ta, ta-ta, ta-ta. Everybody got that down? Because here we go. I'm going to do this example right here. We already know what the answer is. What goes in place of x? 5. But I'm going to show you how to do it algebraically. Working it with algebra. Okay? We've got to get the variable by itself on one side of the equals. So, what is with the variable here? Thank you, Gus. You're the only one. Where are you? You're the only one brave enough to answer that because everybody's scared I'm going to go, oh, no, that's not right. Good job. What's with the variable? Everybody, what's with the variable?
4.
4. Now, do you see that it's a plus here? This is an addition problem, isn't it? Okay. It's different than that over there because those are all what? Subtraction, and what are those back there? What's the slam together mean? Those are multiply problems. Okay, you with me? So these are all add problems. What kind of 4 is this? A positive or a negative?
Positive.
It's a positive. We're going to do the opposite. What is opposite of positive 4?
Negative.
So write a negative 4 underneath it. You better have this example written down because we put a negative 4 underneath it. Because we're doing the opposite. Y'all with me? Opposite of positive 4 is negative 4. Now, picture, there's Cain's side, here's my side, with an equal between us. We are taking 4 pounds away from Cain. To stay equal, what do we have to do to me? Take 4 pounds away. Does everybody agree with me on that? Cain and me. We're minusing 4 away from Cain. We better minus 4 from me to stay equal. Okay? Draw a line. What's a positive 4 and a negative 4? 0. And 0 represents nothing. So the only thing left on this side is x, because positive 4 and negative 4 gives me nothing. So x falls down. We have an equal sign. And now what's 9 minus 4? Is that not what we thought a minute ago? In our heads? Now you may be thinking, well, why didn't you let me do it like I did in the 2nd grade? That's fine until I get all these negatives and stuff in there, huh? What you think? I better know how to do this, right? All right. Now, take a deep breath. Okay, that's one problem. Whoo, doggy. All right. N plus 8 equals negative 2. All right, n plus 8 equals negative 2.
10.
Negative 2. N plus 8 equals negative 2. Okay? I've got to get n by itself. What is with the n? An 8. What kind of 8? A positive 8. What is opposite of positive 8? Negative 8. All right. Now, we're taking away 8 from Kason. What do we have to do to me? Take away 8 from me. So we'll stay equal. Draw a line. What is a positive 8 and a negative 8? 0. And 0 represents nothing. So I have nothing, but I have my n. Is it by itself now? Yes. The 8's gone. Uh-oh. I got negative poop. So I'm guessing we're going to have to remember all of our what? Uh-oh. And some of us had trouble just yesterday going back to our notes and remembering our positive and negative rules. We're going to have to remember all of our positive and negative rules. Well, here's one. A negative 2 added to it a negative 8.
Is a negative 10.
Start at negative 2, go negative 8 more. Where are we going to end up? Negative 10. Y'all remember that? Signs are the same when you're adding. Add the numbers and keep the sign. That's not multiplying. That's adding integers. We're putting it all together, aren't we? So our answer must be negative 10. Whoo, doggies. This is some deep stuff. It's algebra. 5 plus y equals 1. Who do we want by itself?
Y.
Y. Y, okay. So who's got to leave?
5.
The 5's got to leave, so my y will be by itself. What kind of 5 is it?
Positive.
Positive. We got to do the opposite. What's opposite of positive 5?
Negative 5.
So I'm going to go minus 5. Uh-oh, we just took 5 pounds away from Kason. Better take 5 pounds away from me, too. What happens to this 5 and this 5? Nothing. It goes down to nothing, right? Leaving me y. Now, positive 1 and negative 5. Positive 1 and go negative 5. Negative 4. Good job, Sean. I heard you say that, dude. Look at there. We got to remember our positive and negative rules. Signs are different. Subtract them and keep the sign of the bigger number. Is it getting easier? Is it getting easier? That's tough stuff. Okay. Uh-oh. I threw stuff on the other side. Does that matter? The z's on my side, not Kason's side. So what? I still got to get z by itself. What is with the z? Positive 10. I got to get rid of him by doing the What's opposite of positive 10?
Negative 10.
Negative 10. Okay, we just took 10 pounds off of me. I got to take it off of casing. What y'all think? What happens with these guys right here? 0, leaving me Z by himself. Uh-oh. A negative 7 and a negative 10 being added.
Negative 17.
Negative
17.
17. Signs are the same. Add the numbers, keep the sign. Or start at negative 7 and go negative 10 more. Number line still works, doesn't it?
Mm-hmm.
All right, last one on this one. 11 plus A equals negative 11. I got a student tell me the answer is going to be 0. No, we got to work it out. What do we need by itself? A. What is with the A? 11. What kind of 11 is he? Positive. So to get rid of him, I have to do opposite. What is opposite of positive 11? Negative 11. All right, Kason just lost 11 pounds. Did you say do it to the other fat man? Is that what you just said, Raby? Oh, I thought you just said do it to the other fat man. I must do it to me also, don't I? Raby?
Yeah, but wouldn't that be a positive?
Do it to the fat man on the other side. What happens to these guys?
0.
0, leaving what?
A.
A by itself. All right. Now, what is a negative 11 and another negative 11? Positive 22?
No, negative.
Negative 22. Now, Gus, I heard you say 0, Bubba. You're starting at negative 11, and you go negative another 11. 0 is way back here, though, isn't it, nobody? Now, we're going to be out here at negative 22. What do y'all think?
Easy.
You liking it so far? Okay. Now, let's get off of addition problems here. The problem starts off as addition. And let's go to where the problem starts off as subtraction. Okay? Now, keep in mind, Kason and me. It's still Kason and me. Because there's an equal sign. Kason's on this side. I'm on this side. All right. We still want to get the variable by itself. Now, are you okay with that? We still want to get, in this problem, what by itself?
The X.
The X. X needs to be by itself. What is with this X?
Negative 8.
Not an 8.
Negative.
Negative 8. Someone wants to say, but I thought that's subtract 8. Oh, remember what I said? Subtract and negative mean the same thing. So I can think of this as a negative 8. A negative 8 is with the X. What is opposite of negative 8? Positive 8. That's how you get rid of him, so X will be by itself. Do the opposite. Plus 8. All right, Kason just gained 8 pounds.
You got to.
Who has to gain 8 pounds? I've got to gain 8 pounds. Well, we're not equal anymore. We got to stay equal. So if he gets fatter, I got to get fatter. Okay? What happens to this negative 8 and this positive 8? 0, leaving X by himself, just like we want. 2 and positive 8.
10.
Signs are the same. Add them and keep the sign. Positive 10. Or just plain old 10. Just like that over there, wasn't it? Even though the problem started off as subtraction. We do the opposite. Okay, W minus 4 equals negative 5. Oh, got some negatives in there. That's all right. Who do we want by himself?
W.
W. Like Walia. We want Walia by itself. What is with Walia?
Negative.
A what?
Negative 4.
Negative 4. What's opposite of negative 4?
Positive 4.
Plus 4. Uh-oh. Kason just got 4 pounds heavier. Me do too. I got to get 4 pounds heavier. Or we're not equal. We got to stay equal, me and Kason. He's got to stay good looking like me. So he's got to change himself. What happens to negative 4, positive 4? Have you noticed every time what happens? It disappears and we're left with just the variable every time so far? Sweet! A negative 5 and a positive 4. Signs are different. Subtract them, it's 1, and keep the sign of the bigger digit. But if you don't like that, could you do the number line? Start at negative 5, go positive direction 4 step, and where do you end up?
Negative 1.
No, she's good. You're good.
I'm filming right now, so go that way. All right. Okay, where are we? Oh, right here. Now, did I change a bunch of stuff around? No, I just flip-flopped it, didn't I? Does it matter?
No.
No. Where's the variable? And what is the variable? What's the variable? What's the variable? Y. Good job, 10. It's over here on my side. I don't care. What's with the variable? Negative 8. So that's what's got to leave. What is opposite of negative 8?
Positive.
Positive 8. Now, I just gained 8 pounds. Y'all tell me.
So does Kason.
Kason's got to what?
Get it.
He's got to gain 8 pounds. What happens on the variable side? 0, and the variable's left by itself.
Which is
Now, a negative 10 and a positive 8.
negative 2.
Negative
2.
2, right? Subtract them and keep the sign of the bigger digit. Oi?
Oi.
Oi. You're doing algebra, folks. You're doing freshman algebra right now in high school. This is freshman algebra in high school. Swing. All right, what's the variable? Z. What's with the variable?
Negative
A
3.
negative 3, right? What's opposite of negative 3?
Positive 3.
Plus 3. Uh-oh, he just gained 3 pounds.
So do you.
I better gain 3 pounds too, so we can stay equal. What happens on the variable? 0, so Z's by himself. Negative 5 and positive 3. Who?
Negative 2.
Signs are different, so 5 minus 3 is 2. Which one's bigger digit?
5.
5, and his was negative, so keep that negative.
Pretty easy.
Are we swinging along? All right. What's the variable? W. What's with the variable?
Minus 8.
A negative 8. Now, to get rid of him, we got to do opposite. Say opposite. Opposite. What's opposite of negative 8? Positive 8. Uh-oh, I just gained 8 pounds. Kason better gain 8 pounds. What happens on the variable side? 0, so W is just W. Uh-oh, 8 plus 8.
16.
Oh, that's second grade, isn't it, Carson? You with me, Carson? You're gone there for a second. What's the variable, Carson, on the last one here? T. What's with the variable, Carson? Negative 2. How do I get rid of him? What's opposite of negative 2, Carson? Positive 2. Uh-oh, I just gained 2 pounds. Kason has to gain 2 pounds. What happens on the variable side there?
0.
just old T.
And then positive 6.
4 plus 2.
Positive 6.
Positive 6. What y'all thinking so far?
Easy.
Algebra's not quite hard, is it? Quite hard that stuff, no? All right. Last batch. Those were add problems. Now that doesn't mean we necessarily added, did we?
No.
Those were subtraction problems. Didn't mean we really subtracted, did it? We worked it algebraically. Okay? But it started off as an add problem, started off as a subtraction problem. What are these starting off as?
Multiplication.
Multiplication. That is 5 slammed against A. So what does that mean?
You get A all by
5
itself.
times A has to equal 10. Now we already know what the answer is, don't we?
Yeah.
Let's put it over here. A equals
2.
5. 5 times 5 is 10. Come on now, somebody needs to slap. 2. All right. Our answer is going to be 2. Here's where it's slightly different than the first two. So this one might trickle us a little bit. We're still going to do opposite. But opposite of multiplying is dividing. Okay? Okay? So right here, I'm going to write myself a note. Opposite of mult is div. So I'm going to put this in there because on these problems I do something slightly different. I'm not be changing positives and negatives. I'm going to divide. And let's see how this works. Ready? Okay. This is 5 times A. What is opposite of multiplying? Dividing. So I'm going to divide casein by 5. Isn't that what a fraction bar does? Divides? Right? Now, I just divided casein by 5. To stay equal, what do I have to do to me? I got to divide me by 5. Remember up there I said, what if we half him? What if we divide him in 2? Y'all said, well, you got to divide by 2. Okay, same way here. I divided casein into 5 pieces. Cut him up with a machete. Well, what do we got to do to me if we're going to stay equal? Better cut me up with a machete, right? So divide me by 5. What's 5 divided by 5? 1. 5 divided by 5. 1. What's 1 times A? What's 1 times anything? That 1 times anything is 1? 1 times anything is the anything, right? 1 times 500. 500. So 1 times A is A. 5 divided by 5 is 1. 1 times A is just A. Is A by itself? Like it's supposed to. Is A by itself? The 5 left because I divided by it. Because the opposite of multiply is divide. Now on my side, what's 10 divided by 5?
2.
Hey, look at there. That's what we got. We just did it algebraically. Right? We did it algebraically. Because we got to be able to do it algebraically because we'll come into some of these harder problems with negatives and positives. All right, so take a deep breath. Here we go. All right. This is -2 slammed against x. So what does that mean? -2 times x. What's opposite of multiply? Divide. So let's divide by -2. So x will be by itself. Is everybody with me? We got to get rid of the -2 that's multiplied by x. To get rid of multiply, you divide. Now, I just divided casein by a -2. What do we need to do to me? Divide me by -2. All right, what's negative 2 divided by negative 2? 1. What's 1 times x? X. All right. Remember, we wrote up there, you got to remember all of our positive and negative rules. Now I've got division. 8 divided by 2 is 4. Positive divided by negative? Negative. We took a pop quiz on that today, didn't we? X must be negative 4. You okay, Lyndon, on this? This is some deep poop right here now. Woo. Smelly too. Okay. Negative 30 equals negative 6 slammed against y. What kind of problem is this?
Multiply.
It's a multiply. It's got negative 6 times y. What is opposite of multiply?
Divide.
Divide. Okay. They're multiplying by negative 6. I'm going to divide by negative 6, so y will be by itself. I got to get rid of the negative 6 that's being multiplied. Now, I just divided me with a machete by negative 6. What do I have to do to Skinny Boy? I got to divide him by negative 6. Whatever I do to me, I got to do to Kaysen. Whatever I do to Kaysen, I got to do to me. What happens right here? No, not 0. 1, and what's 1 times y? Y. Good. Y is by itself, just like I wanted.
Now work out.
30 divided by 6.
5.
Negative divided by negative.
Positive.
Negative divided by negative.
Positive.
Negative divided by negative.
Positive.
Positive. I keep hearing someone say negative. Took a pop quiz on that today. Woo, doggy. I'll throw my stuff around there. 7w equals negative 28. How about Lyndon? Help me. What are we going to do here, brother? Okay, what about my 7? No, it's not. It's a positive 7. This was negative 6, so I used negative 6. This was positive 5, I used positive 5. Don't be changing the sign. That's on those and those. Okay, what about it? So what math are we doing? Dividing by 7. Because I need the 7 to disappear, so W will be by itself. Thank you, Lyndon. Now, what else do I do now, brother? Where? Oh, you better do it to me too, huh? Right like that? A negative 7 or a positive 7? Yeah, same one. Very good. What happens over here? Seven divided by 7.
1.
1. 1 times W. W. Say W. Thank you very much. Equals. Now, 28 divided by 7? Oh. 4. Negative divided by positive. Negative divided by positive. Yesterday's rules.
Negative.
Negative. Very good. Negative. I'm doing a lot of examples, y'all. But if you got them in there, you can look at them, right? Hey, hey, hey. 60 equals negative 6y. What do we want to get by itself? Y. What's with the y? Negative 6. Now, are we going to plus 6 or are we going to divide by negative 6? Right, because it's a multiplication problem, and what's opposite of multiply? Divide. So divide me by negative 6. That's my side. Books, what do I do now?
Put the 6 on
Okay? Won't you say, divide Cason by -6? There you go. That's why I used him, so we can remember how to do this. I divide me, so you divide him. What happens on my side? Y is by itself, isn't it? 1. 1 times y is y. What happens on Cason's side? What's 60 divided by 6? 10. What's positive divided by negative? Negatory. Look at there. Last one, Lexi. Talk me through it, girlfriend.
The y needs to be by itself.
The who?
Sorry, the x.
Ah, thank you very much.
So you put a line under them for the division. Divide it by -8. -8 divided by -8 equals 1, and then x times 1 by x and x. This one's too simple. -8 divided by -8 equals 1. Do the same thing.
Oh yeah, I'm sitting over there fat and sassy. We divided him by -8. You better divide me by -8. Oh yeah, we weren't equal no more. We took fat Cason, took some pounds off of him, and didn't take nothing off of me. I gotta do it both. Now what do we do, girlfriend?
-8 divided by -8 equals 1. And then 1 times x is x.
Very good.
56 divided by 8 is 7. And then keep negative. Oh, positive. Negative divided by negative.
Positive. Very good. The whole key, y'all, is opposite. Do you notice? Up there, the problems were all addition. What was the opposite of addition? Subtraction. Did we not subtract on every one of those problems to get our answer? I say subtract. We put a minus something, didn't we? Over there, the problem started off as subtraction. What did we do to work the problem? Look right by the red lines. What are all those? Pluses. Opposite of subtracting is plusing or adding, right? Right here, these were all multiply problems. And what did we do? No, we didn't multiply.
Divide.
We divided because opposite of multiply is divide. So notice we do opposite of whatever it says to do, right? If I were to kill it, dude.